Good evening, everyone. My name is Maarten. I'm leading a team at NVIDIA working on synthetic data generation. And so today I want to talk about, the fuel that basically powers up all these AI applications and models that we're building, which is data. I want to talk about, how we move from mining data, collecting data, to manufacturing it, designing it, synthesizing it, and scaling it up. And doing it in a way that's actually open and, foster collaborations for the entire community. So if you're building AI applications today, so the reality is that you're facing some data bottlenecks. If you want a model that is highly accurate, you need to feed it high quality data, right? If your data is outdated, biased, unreliable, chances is that your model's utility is going to drop, right? Secondly, is privacy. There's a lot of data available that is locked away in silos. I'm talking about customer data, production data. You cannot use it. Government regulations, internal rules doesn't allow you to use that data to build models. Third, if you want to build, a very domain-specific model, chances are high that there's not a lot of data for that particular domain present, right? So it doesn't come in large volumes. And then fourth, you can collect data. You can have human annotators looking at the data, annotating it, labeling it, but that's very expensive. It's also delays your innovation, right? So you cannot really iterate. If you cannot iterate, you cannot innovate, right? So all these four factors combined basically limit the innovation velocity. So what is the strategy at NVIDIA for as a solution for this is basically transparency, right? So we've seen it before. Brian also mentioned we're open sourcing, the models, open weights, but also the data sets, the ingredients, and the recipe to build those models, right? So we want you to trust our models, and to trust our models, we want to give full transparency. Secondly, also, we want to enable all of you, whether that's academic researcher, startup engineer, if you want to build those very competing frontier models, you need access to massive data sets, right? It's not proprietary data sets, so we want to give you access to all these data sets. And then lastly, we want you also to reproduce our results. We want you to replicate our results, to validate the claims we're making on our models, and you can basically reproduce the models, or you can take a data set out of the data set we use for pre-training and post-training and build your own model. So this comes in, so that's why we open source all these Nemotron data sets. It comes with a whole suite of data sets. We have pre-training data set, post-training data set, reasoning data sets for safety to make sure the model stays factual and accurate, but not harmful. And then also lastly, we are adding sovereign AI data sets. So these are data sets like Nemotron personas, Nemotron PI. These data sets are actually grounded in demographics, in region-specific demographic distributions that allows you to build data sets for your region, your domain, all over the world. So we want you to you can use those data sets to basically build other data sets on top of it, or use them for model training so that that model doesn't reflect the distribution of the internet, but the distribution of the real world. And so that leads to a topic that I've been working on for some while right now, which is synthetic data. And I want to just give an overview of how synthetic data techniques have evolved over time. So in the beginning, we started with basic rules, some Python code strips, libraries as Faker. We used to create data sets that are lacking variation, very rigid, very good for test scaling your applications, but doesn't really have intellect records in those data sets. The other techniques are statistical modeling, so you define your distributions, you generate data from those distributions, but also here it lacks deep semantic meaning. Then we move to single-purpose AI models like GAN-based models or LSTM models. Basically, these are fine-tuned on your data, and they're very well in representing and creating a synthetic version of your data set that corresponds to the same statistical properties of your data. But also here, they don't generalize as well, right? They're very good in replicating your data, but not generalizing to unseen conditions. Fourth is, general purpose LLM. So many teams are actually using that. You take an LLM, you do a lot of prompt engineering, you run inference against those LLMs, and basically these LLMs have, they understand semantic meaning, they have an understanding of the world. But, issues here also is that they can hallucinate, they're not very good in, solving edge cases. If you want to generate 1 million records and those records need to contain street addresses, high chance that you will see 1 to 3 Main Street a lot, right? Also not very good in generating numerical data, distributions, and whatnot. So the solution we actually propose is to build those compound AI systems, which is basically a framework that orchestrates multiple models and tools together to make these interconnected data sets, right? And those data sets allows you to solve use cases, build high quality data sets that you can use to fuel AI applications. And so this is actually what we built at NVIDIA, which is called NeMo Data Designer. It allows you to generate this high quality domain specific data from scratch or seeds. And the way it works is that you provide some inputs, which is either some prompts, some seed data, your own data. You design your configuration, your workflow, you select the model you want to use, set your inference parameters, build your synthetic data generation workflow. You validate, you iterate, you look at the data, you inspect the data, and you do this over again. So you basically design your data, and if you're happy with the result, you scale it up, and you do like a large batch generation job. Your data comes out. You have a quality report. You can do intrinsic evaluation of your data set, and then do ablation studies or extrinsic evaluations. So a very customizable and scalable approach. So it's a little bit of software engineering your data set, right? So you build up a pandas data frame, as you will, one column at a time. And every column basically represents a building block, a column type that you see here on the left, which are seeds, sampler. There are LLMs involved, but not all the tools here are LLMs. We have validations. We have blocks that create structured data, and also something like plugins. So you can build your own plugin that you then, you have your own, Python code, or something very specific to the data set you want to build. You can plug it in and make it part of that workflow. And then all these building blocks combined, you can then create, endless combinations of it in a dataset builder workflow. So, for instance, here, it's a simple graph to create a text-to-code dataset. You start with some seeds and some samplers. You want simple, advanced, complex text-to-SQL queries, let's say. You feed it in an LLM to create the natural query. Then you create a SQL code, the DDL schema from that, that's the third level there. And then you ask an LLM as a judge to basically verify if the query corresponds to the natural question. And then you can use a validation step. Basically, these are SQL linters that basically check for syntactic correctness. And then you can build layers on top to basically correct records that were that had syntactic problems, or had low LLM as a judge score. So you can build iteratively. You can design that workflow to create that data set. We're also building an entire feature ecosystem around Data Designer. So a lot of features are available to generate these high quality data sets. It goes from, previewing your data sets to generating large scale batch jobs. We're working on, expanding into other modalities like image, speech, video, audio. We have these validators that allows you to do code linting and other things if you want to do a text-to-code data set. LMLs judged structured outputs. So if you want to create, for instance, a synthetic data set that needs to follow a certain JSON schema, we have a feature for that validates that and retries the generation. And if it fails after a certain amount of retries, you just drop the record and you continue with your generation. So one feature I want to specifically focus on is personas. This is a feature that's also part of Data Designer, and we also have released those Nemotron personas datasets. We worked quite hard on this, and so the reason I want to highlight this is that many datasets that are out there, they are biased, incomplete, are ungrounded, and if you want to build datasets that are linked to some demographic distribution, you can use census data, for instance, but that's also way too sensitive to use, right? So the way we built this feature is to use probabilistic graphic models that are grounded on census data. We sample from this large census data distribution. We combine it with ocean traits, so we sample from that, and then we use an LLM to basically combine these two in order to create personal attributes, right? Those personal attributes can then combine by another LLM call to create all these personas, and this gives you this very rich and culturally grounded persona data set that can be used to fine-tune sovereign AI models. We have released it for the US population, we have released it for Japan population and for the India population, and more locals are coming, and many more countries are interested in expanding our feature to their country. So this is talking about what you can make with it, but how can you now actually create those data sets? So we're having an SDK, a Python SDK library, which in 5 steps, very easy step list allow you to generate such a synthetic data workflow. The team has been looking very hard in making this as user-friendly and as least of a learning curve as possible to learn that Data Designer flow. It's very intuitive. So you import a function, you set up some model configs. You can use model endpoints on build.NVIDIA. You can use any OpenAI compatible endpoint. You can bring your own model. You then build the designer, the design config. You add columns one step at a time. You can preview the results. You can look at the data. If you're happy with the results, you can scale it up. And so, you can create your entire data set. How can you use Data Designer? You can go to build.nvidia.com. It's part of our NeMo platform. But what actually all building up to this slide here is that today we're actually open sourcing Data Designer. So we give the entire community under an Apache 2.0 license the Data Designer tool. It's free to use. Please just install Data Designer. That's all you need to do. It's been work in progress for the last 2 years. We've built a lot. We thought a lot about design. We thought a lot about how we can make such a compound AI system in a Python SDK library, and today it's available. Just want to show this slide here that obviously we're releasing a lot of tools. We have NeMo RL, NeMo Evaluator. These are all also open source tools that we release. So NeMo Data Designer fits right in the front of this AI lifecycle here. It solves the cold start problem. It gives you access to the data you might not have to build your AI application. And this is the last slide, just wrapping things up. I really like showing this graph here. This is a prediction by Gartner in 2020 that by 2030, the amount of synthetic data will overtake the amount of real data in building AI applications. Now, when I showed this 3 years ago, people were skeptical, you know, how can synthetic data be as good as real data? And in certain domains, you know, it's very hard, you know, real data might still be better. A year ago, people were actually seeing this trend happening, and today I actually want to say that maybe Gartner was not right enough. I think this curve is more exponential. Synthetic data is used in any model trainings at a way higher volume that people might even think a couple of years ago. So 3 key takeaways here from this presentation. First of all, I want everyone to start thinking that data has shifted from mining to manufacturing, right? You want to architect intelligence, and you can do that by designing data. And you can do it for your privacy and budget constraint, and also for the domain you want to do. And a tool like Data Designer allows you to do that. There are many good tools around. I think, you know, Data Designer, we would like to make it the industry standard, and that's why we open source it. Second of all, quality over volume. It's been said before that, you know, if you make your data set smarter, you can accelerate the training. You know, pre-training has been accelerated by 4x from from what Brian said, just by making the data set smarter. And so this is also a community opportunity. So it's a question and ask for everyone to, you know, collaborate with us on this Data Designer library. You can innovate on domain-specific generation recipes and standardize that. You can create a data set, release it on Hugging Face, and also share the Data Designer config so everyone can actually reproduce you know, your synthetic data. A new model comes available. You can rerun that configuration with a better backend model, for instance. And so, yeah, so we'll give you all the tools to create smart data pipelines. These are the 2 links I would like to share. First is the Nemotron open dataset, and then the second one is the link to our GitHub repo of NeMo Data Designer. You can, you know, like I said, pip install it, clone the repo, get access to all the source code there, and if you like it, please give us a GitHub star. Thank you.